Alright guys, what is good? It's your boy Grape back at it again with the 1988 ajhsme problems. Let's take this ajhsme test and let's see how we do. Alright, let's get started in 5, 4, 3, 2, 1, and 0. Alright. Problem 1. The diagram shows part of a scale of a measuring device. The arrow indicates an approximation reading of... Okay, so this is 10, this is 11. Let's see how many jumps it takes us to get to 10 to 11. 1, 2, 3, 4. That means all of these lines is basically 1/4 of the way there. So this is 10 and 1/4, and this is 10 and a half. So basically, what number comes in between? Not this one, not this one. Yes, this one. No, sorry, not this one. That's 10 and a fourth, and it's not on the line. And this one does, and this one doesn't, which means our answer must be D. Okay, so we're gonna have like a answer sheet kind of thing next to us to make sure we're getting our problems right, because I don't want to be showing you guys the wrong stuff. So yes, it's D, as we can see right. Oh wait, over here, you guys. Anyways. So, and just know I can do a lot of these problems a lot faster, but I have to make sure all of you guys can understand because we're all at different skill levels. Alright, 8 times 2.5. So, 4, so 1/4, and 4 1/4 equals 1, and there's 2 times 4, so this is equal to 2 times 2, which is equal to 4 times 1.25, which is equal to, like 1/4 of 1,000, basically. So basically our answer is going to be D1. We can go ahead and check that now. Problem 2. Did I just get this wrong? I'm so disappointed in myself. Let's try this again. Hold on. I saw the answer as C. Let's try this again. See, you guys, I'm rushing and I can't concentrate. So that's 2 times 2. That's going to be 4 times 1.125. Which is, oh yeah, which equals 0.5. So yeah, I rushed too fast and I got it wrong. So that's what you never want to do in these. Alright, let's go. Is that right now? C? Yep. Alright, let's go ahead and do this. So you're gonna want to basically simplify all these fractions, and it turns out that it's just 1/10 plus 1/10 plus 1/10, which is just gonna simplify into 3/10, which in decimal form is not 0.1, not this, but D, and not E. So let's go check our answer. Is it D? It is D. Problem 4. Okay, so the figure consists of alternating light and dark squares. The number of dark squares exceeds the number of light squares by, so we have to figure out how many more of each square there is. Of how many more dark squares. Well, and this is also the same, you guys. So it's just that they didn't want to draw it because, time. Anyways, so basically, if we look at each row by row, we can see that every time there's one extra black square, and that pattern will continue down here. It's just that we don't see it. As you can see, I'll quickly make it for you. Okay, so let's go. 1, 2, 3. Okay, we'll just look at the first 3 rows, and here it's 0, 1, 2. So basically, it's just these numbers added 1, 2. Okay, so let's take a quick look, and we see that basically there's 1, 2, 3, 4, 5, 6, 7, 8 rows. 8 rows. So we're going to be exceeding by 8 because in every row there's 1 extra. Problem 5. If CBD, which is right there, is a right angle, then this protractor indicates that the measure of ABC is approximately, so this is 90 degrees, okay? ABC. Okay, so if this is 160, 160 minus 90 what is that going to give us, guys? That is going to give us 70. So basically right here is 70, and then the angle measure between these two, because we're looking for ABC, it's going to be 50, approximately, according to this. Okay? Oh, man, we have to keep checking. So 4 is B, yep, and 5 is C, correct? Is that what we got? Yeah, let's go, guys. Okay, so 0.2 cubed. Oh, no. Okay, I don't like this. Okay, 0.2 cubed is just going to be 0.2 times 0.2 times 0.2. So we just multiply like we usually would. We get 8. And since there's 3 numbers on the right of the decimal, you're going to put 3 numbers on the right of the decimal. You get 0.008, correct? So let's get rid of that really quick. So this is equal to 0.008 over 008, you guys. 0.02 multiplied by 0.02, because this is just a square, the other one was a cube. We get 4, okay, and there's 4 things, so bam. So 0.0008 divided by 0.0004, it's just going to become 8 divided by 4, I think, right? Come on, Kabir, you can do this. Come on, Greg. Let's go. Yeah, I was talking to my friend Kabir over there. He's watching me. He's writing some stuff down too. I'm hoping he can get this one. If I don't, 0.4. Yep, it's 2. Alright, B2. Let's go ahead and check. Okay, come on, guys. We got this. We're doing this like a breeze. I have no idea how they did this. Okay, sorry about that. Oh, obviously, because there's 3 zeros, so you have to multiply by 10, and then you multiply by 2. Alright, guys, did you see what I did there? Because it's not, oh, so I miswrote it, that's why. So it's going to be 0.008 over 0.0004. So there's 3 zeros, so you have to multiply by 10 to make it, basically 0.008 over 0.004, and then you multiply by 2 to get that. So basically it's 2 times 10, which is 20. That is so bad of me. I couldn't think. So for this one, I think what you would do is you would round 3 times 8, which is what, you guys? That's 11, but first parentheses, so 5.17 plus that. So if we round, we're going to get 5 plus 5, which is 10, and 11 times 10, that's 110. So I want to say it's closest to A100. Let's go ahead and check that out. Problem 7 is B200. Yay! Okay, so we estimate the first thing to be 2. All right, because you have to the second thing to be 8, and then the third thing to be 10, and now we have 2.5 times 8 times 10, 25 times 8, 200. Okay, don't know how they did this one. Okay, so basically, if you were to solve the whole thing, you'd get this right here, 200.78971902. And yeah, and then you can just round it to 200. So there's lots of ways of doing that one. I don't know why I didn't get that one. I should have. It was so easy too. Okay, so oh yeah, okay, so now. So all right, so that's gonna be 2.5 times 8, right? Because that's the closest. And then 2.5 is a lot closer to that. And then 5.17 plus that. I would do 5 plus 5, that's 10. And then 2.5 times 8 is... Oh, but we're multiplying everywhere, so 25 times 8, that's exactly 200, which is what you would need, right? So, 1 second, guys. Alright. So, I'm sorry, I got that one wrong. Okay. So, Betty used a calculator to find the product of blah, blah, blah. She forgot to enter the decimal points. Calculated. If Betty had entered the decimal points, the correct answer would have been... I don't know. Well, she forgot to enter the decimal points. Okay. Okay, and then, so basically what she did was she did exactly what she was supposed to, except she didn't add basically. Okay, here, let me show you what I mean. So she did 75 times 256, okay? Now, what would you do if you were really doing this? You'd do exactly that, but you'd have some extra numbers, and you'd have a decimal, and you'd have a decimal here. And then after you multiply it out and got 19,200, you have to take how many decimals are up here. So she forgot to put her decimal points, which is okay, but there would have been 3 and 4, 5. So 1, 2, 3, 4, 5. So all 5 of the numbers are supposed to be right there. And yeah, so the correct answer would have been B. Okay, let's go ahead and go check that out. 8, and that's perfect. It's B. Alright, an isosceles triangle is a triangle with two sides of equal length. How many of the 5 triangles on the square grid below are isosceles? Okay, well, we see this, and this is isosceles because we have 2 equal sides like this, and then we have this. This one, which I'm seeing right here, I think, is also isosceles. This one is not, because 2, 3, and then that one's just 2. Yeah, this one is not, because it doesn't have... Wait, is this one actually? Yeah, this one is, because 2 and 2. So perfect. At least 2 of them are. And we know 5 of them aren't. And we know 1 of them aren't. And then, we'll come back to this one in a second, because... Hold on. Wait. So that's 2. And then this is not going to be 2, because this is... We're going to have to use Pythagorean theorem, which is 1 squared plus... and then 2 squared, and then you add them to get this side, and then you square root them to get that side, which is the square root of 3, which is not equal to 2. And this is not either of them. This side right here. So basically, this is not. So we know it's not that. Okay. And so we can use Pythagorean theorem here again. And we see that this one is. You can use Pythagorean theorem by going 1 squared plus 3 squared, which is 10. So this would be the square root of 10. And same with this side, which means that's isosceles. So we know it can't be 2 because we found 3. And now this is the deciding one. So this is going to be the square root of 10 using our Pythagorean theorem. This is going to be the square root of 5. And this is the one that decides it all. It's going to be the square root of 5. So if I'm right, the answer should be 4. Let's go check it out. Yes! Perfect. 9 is D. Right? Chris's birthday is on Tuesday this year. What day of the week will it be 60 days after his birthday? Oh no! I suck at these problems, guys. Just no. So let's see. So it's on Tuesday. So what will it be 7 days later? So Wednesday, that's 1. Thursday, that's 2. Friday, that's 3. Saturday, Sunday, Monday, Tuesday. Let's see how many days it takes to get to the next Tuesday, actually. So 1, 2, 3, 4, 5, 6, 7. Perfect. So we can do 60 divided by 7. And now, that's going to be 8. So that leaves a remainder of 4. Now, most of the time you want to get rid of that remainder and bring it down to a decimal, but this time we don't. So that 8 is telling us that we've made it all the way back to Tuesday. So now we can add 4 days to Tuesday. So 1, 2, 3, 4. Our answer is Saturday. And if I'm correct, that's what it should be. I suck at this, you guys. I'm telling you. 7 days after her birthday would be Thursday, as would be 56. No, don't tell. Oh, I thought this said Tuesday. Oh my god. So I was so close. I just thought it was the wrong day of the year. So week. So 1, 2, 3, 4. It should be Monday, and that's exactly what our answer key says here. A Monday. Okay. So I was right. You can do exactly what I did, except I just used the wrong day of the week. Alright, now we have to find the square root of 164. So we know it's not going to be 42 because 13 squared is 169, so 42 is too big. Less than 10, that can't be right because 10 squared is 100, so it's not less than 100. Between 10 and 11, now 10 squared is 100, so yes, but 11 squared is 121, and it's not less than 121, so it's not this one. And then same here, 12, 144, too small. And then 12 and 13 is a perfect fit. And also, we've eliminated the rest. So if I go to 11 on the answer key, we should be getting E. E. Perfect. So now we've kind of come out of our comfort zone, and now we're going to start finding harder problems, most likely. So suppose that the estimated $20 billion cost to send a person to the planet Mars is equally shared by 250 million people in the U.S. Then each person's share is so if 250 million, so let's find out how many million go into a billion. How many 250 million? So 250 million goes into 1 billion 4 times, and there's 20. So 4 times 20, that's gonna get us 80. So that means if each of the 250 million people in the U.S. will pay up $80, we can send a person to Mars according to the estimation that it's $20 billion of cost. And if we go check our answer, we should get perfect C80. It's exactly what I wanted and exactly what we needed. Now, if rose bushes are spaced about 1 foot apart, approximately how many bushes are needed to surround a circular patio whose radius is 12 feet? So, 1 foot apart, approximately. Okay, so what you need to know is how to find the diameter of a circle, which is not the diameter, what are that? Circumference, which is d pi. Approximately how many bushes are needed to surround a circular patio whose radius. So radius is 12. The diameter is going to be 24, and then we can multiply by 3.14. Multiply 4 times 4, that's 16. 4 times 1, that's 4, plus 1, that's 5. 4 times 3, that's 12. 2 times 4, that's 8. 2 times 2, that's 2. 2 times 3, that's 6. Add them together, you get 6. And then 5 plus 8, that's 13. Carry over the 1. 2 plus 2 is 4. Plus 1, that's 5. That's 7. And then, so that's basically going to give us 7526. There's 2 decimal points. So 75, 0.26. So, yeah, so that's about 75 feet. And if we have to give 1 foot of space to each one, oh no, yeah, you'd get about 75, assuming that the rose bushes don't take up any space. So let's go look at the answer, hoping it's D. I want to be right, you know. Okay, perfect, it's D. Alright, so star and triangle are whole numbers, and star times triangle, or diamond times triangle, equals 36. The largest possible value of that is, so what you want to do now is you basically want to just look at all the what do you call it, kind of like factors that go into 36. So let's go ahead and do that. So 6 and 6, so that would equal 12. We have 12 and 3. We have 36 and 1, which is actually a very strong pair. Okay? So far it can't be this. It can't be this. 4 and 9, which it also isn't it. And I'm not seeing anything that's gonna work besides that. I mean, sure, there's more factors, I bet, like 2 and 18 and blah blah blah. But the thing is, 36 plus 1 equals 37, and that's our largest choice. So we're gonna go with that because I know it's gonna work. So, like, I know it's a possibility, and if it's the highest, it's probably right. So 37 is the largest. Yep, that's perfect for us. So now let's go on. So the reciprocal of 1/2 plus 1/3 is, so for all of you who don't know what a reciprocal is, the reciprocal of 1/2 would be 2 over 1, basically it's a 2, or like 3/5, it's going to be 5/3. It's basically where you just trade the top and bottom, like where the numerator becomes a denominator and the denominator becomes a numerator. So 1/2 plus 1/3, first we have to get that into common terms, so we're going to get 3/6 plus 2/6 equals 5/6, and we get 6/5 when the reciprocal is found. So if I'm right, we get C. So yeah, 15 is C. That's perfect. Alright, now let's move on to 16. Placing no more than one x in each small square, what is the greatest number of x's that can be put on the grid shown without getting 3 x's in a row vertically, horizontally, or diagonally? Okay, so x, 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 x. And then if we add x's anymore, we're going to get 3 in a row, in some ways, so 2, 4, 5. So now I'm seeing E is 6, so I'm going to quickly look around. So if I go there, that's no. If I go there, that's going to be a no. If I go there, that's a no. It was very close though. And if I go there, it's a no. So I think it's pretty safe to go with D is 5. Because it's really close to the highest answer, which means that they're trying to mess with you. And it is E6. Okay, so it is E6. So let's go ahead and look at it. So if we go bam, bam. So you can't go here, you can't go here. So let's put O's there, meaning we can't. We can go here. That's all I can see now. Okay. X, 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 X. Now I can't go anywhere. It's a problem. So basically we're going to have to get rid of this X. And if we put it here, that means we can put it here. And then, that's 5. We need to find one more place. And it's going to be right here. No. What if I get rid of this one? This here. But no, that doesn't work. Oh, sorry, that stays there. That can go away. That can stay there. And then if I go like there. This one I'm not sure, so let's go ahead and call up one of our friends. So okay, it seems like he's not picking up. Let's go ahead and try. May I speak?
Yeah, sure.
Alright, so I need help. Shamgus, let's go to our personal chat. Alright guys, we're calling up Changus. Let's see if he can help us. Okay, Changus. So here on the 1988 AMC8, the ajhsme problem, we have problem 16 where you have to place as many x's as you possibly can. Where would your x's go without making 3 in a row?
You just make a plus, right?
No, but that's 3 in a row.
No, look. So you place it in the middle top, middle right, middle down, middle left. Sorry.
Like that?
I think so, yeah.
No, because you can have more. I know what the answer is. The answer is E6, but I can't figure out how to arrange it for them.
Many? Oh.
So you can do that, and then you can do this, and then you can do that. And then you can do this. This is the max I can find. I can't find any more.
You can also do it bottom right.
No, because then this makes it 3 in a row.
Wait, show me the problem. Like, show me
Okay, here I'll read it to you. Yeah. Placing no more than one x in each small square. What is the greatest number of x's that can be put on the grid shown without getting 3 x's in a row, vertically, horizontally, or diagonally?
Oh, okay. Okay. So it's E6?
Yeah, it's 6.
Look at the solution.
It says by the pigeonhole principle.
Oh, pigeonhole. Do you know pigeonhole principle?
No.
So basically, just search up the pigeonhole principle. I'm not a good explainer, but
Okay. So pigeonhole.
It's really helpful for competitions.
Okay. So in mathematics, the pigeonhole principle states that if n items are put into m containers with n is greater than m, at least one container must contain more than one item. In layman's terms, if you have more objects than you have holes, at least one hole have multiple. Okay. If you have 3 gloves, then you have at least 2 right hand.
It's really trivial. So for example, let's say you had n balls, and you had, or let's say you had like 14 balls, and there are 5 boxes.
Yeah.
And that means that at least one of the boxes are gonna have more than one ball, right?
Yeah.
It's basically the same. Wait, so read the explanation to me.
Okay, so by the pigeonhole principle, if there are at least 7 x's, then there will be some row with 3 x's. We can put in 6 by leaving out 3 boxes in one of the main diagonals.
Hold on, wait, so you have 1, 2, 3, 4.
Oh, I get it. No, because that's 6. That's 6, yeah, there we go.
Yeah.
Alright,
Yeah.
cool, thank you, Chamgus.
I didn't really do anything, but yeah.
Sure. Alright, guys, so that's how you would do it. Okay, so now we have no 3s in a row. Alright. Sorry, that one was confusing. Okay, problem 17. The shaded region formed by 2 intersecting perpendicular rectangles in square units is the shaded region. Okay. Alright. So, let's go ahead and split this into pieces. Wait a second. Okay. So we know this long thing is 2 times 10 right here, right? So this is going to be 20. And this is 8. But you can't have 2, so that's going to be 6 times 3, bam. So this is 2 in the middle of the 8, so 8 minus 2, that's equals to 6, and if it's evenly divided over the 2 sides, it's going to be 3 up here, 3 up here. So 3 times 3 times 2, so 3 times 3, that's 9 up here, 9 up here, down here, and then you can add it all together, and you get B38. Let's go check that out. Sorry. Alright. Yep, it's B. Let's go, guys. Getting good at this. Okay, 18. The average weight of 6 boys is 150 pounds. And the average weight of 4 girls is 120 pounds. The average weight of the 10 children is... Alright, guys. So the average is basically... what we need to know to solve this is the average of something is when all of it is added up and then divided by the amount of it. So here's an example. So I have a boy who's 20 pounds and I have a boy who's 40 pounds. Okay, this is very unrealistic, by the way. No, is it? No, nobody cares. Okay, it's math. So 20 plus 40 equals 60. And since I added two things, I'm going to divide by 2, and the average is 30. Okay? So the average weight of 6 boys is 150. So if we want to find what all 6 boys added up to, it's going to just be 150 times 6, right? So it's going to be, give me a second, 900. And 4 girls is 120 pounds. So it's going to be 4 times 120, which equals 480. Man. Okay. So now we can add them together and we get 1,380. And since we want the average, and since we added up basically 10 terms, because there's 6 boys, 4 girls, that's basically 10 terms, we're going to divide by 10 and get 138. So 18 is C, 138 pounds. What is the, okay, for next, let's go make sure that's right before we continue. Sorry guys, this is such a long video. Didn't mean it to be. Come on, give me the answer. C, 138. That's what we got, right? Yeah. What is the 100th number in the arithmetic sequence 1, 5, blah, 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 blah? Okay. So what we need to know for this one is what an arithmetic sequence is. An arithmetic sequence is when you add up a certain amount of numbers. So when we add, what do we add from 1 to 5? We add 4. From 5 to 9, 4. So it's continuously 4s. Right, guys? Alright, now that we know that, it's added up 4 times. So, and we know the first term is 1 because that's what it's showing us here. So now if we're trying to find the 100th term, what we have to do is we have to multiply 4 times 99, because that's how many times it's going to be added if it's the 100th term, because you don't add 4 for the first term. So 4 times 99, and we get 396, I'm pretty sure. I'm going to make sure. 9 times 4. 6, 3, 36, 39, 396. Bam, guys, I just did that in my head. Okay, it's 396. Bam. That should be your term. And then, yeah, you have to add 1 because 1 is our first term. So we get, well, A, 397 if I'm not wrong. Let's check. Bam! Alright. So, the glass gauge on a cylindrical coffee maker shows that 45 cups are left when the coffee maker is 36% full. How many cups of coffee does it hold when it's full? So it's 36% full, which is 36 out of 100, which is 18, 50, 9, 25. I think that's the max I can take it to, actually, which is not good. Oh yeah, okay, this is good actually. Okay. So now, there's 45 cups when it's 9/25 way full. So 9/25 equals 45 over blank. 45 over the total, right? So now to find what the total is, we can see that 9 times 5. So the total is just going to be 25 times 5. You get 125, you get 45 over 125. Okay, so that's 9/25, and that's exactly what we needed. So our answer is it can hold 125. That one didn't make a bunch of sense. So later on in our videos, we're gonna post a ratio one, which I think that one we might go over this, which will help you guys. So the answer should be C to this one, and yes, it is, sir. All right. I didn't read that one. Don't worry about it. Okay, so 21. We're getting into the top 5, you guys. A fifth number n is added to the set 3, 6, 9, 10 to make the mean of the set of 5 numbers equal to its median. Okay, the number of possible values of n is blank. Alright, so to make a mean, which is actually the average, okay, equal to its median. Okay, so let's go ahead and look at our options. Okay, so if it's 1, our median becomes 6. Okay, so is our average 6 if there's a 1 here? So 1 plus 3, that's 4. 4 plus 6, that's 10. 10 plus 10, that's 20. 20 plus 9, that's 29. And I already know it's not 6 because we're trying to add up to 30 since there's 5 terms and 6 times 5 is 30. So they need to all add up to 30. So it's not 1. That's good to know. Now, if we put in a 2, which is also less than 3, and the median will remain 6, and we need it to add up to 30, and we know that 1 plus all of these numbers equals 29, and that 2 extra, here, let's just do the math. I'm sorry, I'm being confusing. So 2 plus 3, that's 5. 5 plus 6, that's 11. 11 plus 9, that's 20. 20 plus 10, that's 30. And then you divide by 5 and you get 6. So that means 2 works. And now and if you had time, you could come back. No, this is the wrong problem. I'm so dumb. Okay, well that's okay. Guys, so 3 is C. 21 C. Oh no. 21 is C, isn't it? No, I mean B, isn't it? Because 2 plus 3, that's 5. 5 plus 6, that's 11. 11 plus 9, that's 20. 20 plus 10, that's 30. And if it's 2, the median is going to be 6. Oh, the number of all values for n. Okay, what numbers does it work for? Works for 2. It works for 2. Which we actually didn't mean to do. Okay. And then let's try the number 3. That won't work. And then this is kind of like a casework. I would do more, but it's kind of time consuming. And so let me just quickly find our numbers. I think it would be. Okay, hold on. Give me a sec, you guys. Yeah, so it would work for 7. So we know it works for 2 and 7. What's the last number it would work for? Would 8 work? Don't think so. That's 28. 8 times 5, that's 40. No. I don't know what else it would work for. Let's go check in their solution. 3, the median is. So what did they do? Oh, that's pretty smart. So they assigned the median. And so then it became, they assigned the median, yeah. So 3 plus. Okay. Okay. I get you. Yeah. Yeah, I get you. So the possible values are 2, 7, and 17. Okay, guys? You can go look at that solution and pause it there to understand more. Okay, so Tom's hat shop increased all original prices by 25%. Now the shop is having a sale where all prices are 20% off these increased prices. Which statement best describes the sale price of an item? So everything costs X. Then it increases by 25. So we're going to get 5/4 X. And then 1/4, I think. Yeah, now the shop is having a sale where all prices are 20% off these increased prices. And 20% is just 1/5. So what's it's gonna become 4/5 times 5/4, right? So times 4/5 because the price just decreased. Okay, here, let me write this out better. So x times 5/4 equals 25% increase. And it also equals 5/4 x. So then 5/4 x times 4/5 equals 20% drop, and also equals just x. So yeah, so the sale price is not higher, no. The sale price is higher, no. The sale price is higher than the original, no. The sale price is lower than the original price, no. The sale price is the same, which is exactly what we're looking for. And if I go check our answer on problem 22, it is E. Let's go, guys. Good job, we did it. So Maria buys computer disks at a price of 4 for $5 and sells them at a price for 3 for $5. How many computer disks must she sell in order to make a profit of 100? So Maria buys computer disks at prices of 4 for $5. Okay? So for each one she buys, it's going to be 5/4 of $1. And sells them at a price for 3 for $5, which means each time she's going to gain each one is 5/3 of $1. Okay? So she basically loses 5/4 and gains 5/3. Now if we put that into like common terms, we're gonna get 15/12 and 5/3. That's 20/12. So it increases by 5. She gets 5/12 more money. Okay, and if we're trying to get a profit of $100, and she's gaining 5/12 per disc she sells, how much would 100 become? 5/12, 100 would just be, okay, it'd be 1,200 because 100 times 12, so it's kind of in common terms. So 1,212. How many times does that go into that? The answer to that is come on, Kabir. Grape. Yeah, Kabir, you need to write this down too. Are you getting this? Sorry, Kabir's my little brother, and I'm making sure he can do this stuff as well, because stuff. I'm just gonna write it out. I can't math anymore. I'm too tired for this. Okay, divide by 5. That's 2 minus 10. That's 24. 240. Bam. D. She must sell 240 discs. Man, that's a lot of discs to buy and sell. Can we please see problem 23? D. Perfect. 24. Right here. I'm gonna get rid of this work because I don't want to see this. It's too distracting now. Okay. So the square in the first diagram rolls clockwise around the fixed regular hexagon until it reaches the bottom, in which position should will so confused. Wouldn't it just be C? You guys, I don't know what's going on. I can nearly bet it would be in C, but there must be something going on. Let's see. 24C? No, it's A. Okay, obviously. Oh, I understand now. Okay, it's not that the box is turning, not the whole hexagon is turning, the box is turning. So then in this diagram, it would be like this, right? Because this is the side it's sitting on. Turns clockwise, it's this side. Becomes this side. And it becomes this side, I think. right? And yeah. But it says the answer's A, right? It's not E, is it? Is it E? Please be E. Okay, the inner. Okay, so. No. Oh, yeah, I just can't think. Oh, yeah, because I forgot to turn it 90 degrees. But it's only turning 90 degrees, so then technically, wouldn't it be B? Okay, so that was right. Yep. Oh, wait, you guys. Did I make it that's the top? Did I write that? Okay, so. Oh, yeah, so this would be the top. And then this would be the top. Okay, so it is A. Yeah, that one's a little confusing. Alright, a palindrome is a whole number that reads the same forward and backward. If one neglects the colon, certain times, the colon, certain times displayed on digital watch are palindromes. 3 examples are, how many times during a 12-hour period will be palindromes? Okay. So what you want to do in this one is you want to start with the smallest number, which is 1, and then the middle number. It can be 01, like it is here, or it could be 111. And then, oh no, this is going to go on forever. 1, 2, 1. Okay, I see where this is going. So it can be either 0, 1, 2, 3, 4, or 5 in the middle number. So that's 6 possibilities if the hour is 1. So 6. Now for 2, it's once again going to be 6. 3, 6, 4, 6, 5, 6, 7, 6, 8, 6, 9, 6. But now it's going to get different because 10, it can be 01, and that's it, right? Yeah, that's all. So for 10, it's going to be 1. And then for 11, though, it's also going to be 11. So 11, it's going to be 1. And 12 is also going to be 1. So 1 times 3, that's 3. Plus 6 times 9. No, 6. 1, 2, 3, 4, 5. I forgot 6. Haha. Our favorite number. Okay. Yeah, so 6 times 9, which is 54. 57. The answer should be A. 25. Am I correct? Please be A. Please let's end off on a good note. Let's go, guys. We got it. We did it. And that's epic, okay? Alright. Congratulations, guys. You just walked through the entire 1988 ajhsme problems, and we got them all right here on AOPS. You just need to search this website's name, click on it. Don't even have to register. It's better if you do, and it's free that way too. But still, don't worry, we're not sponsored or anything. I don't know why you'd worry, but it's a perfect site. Get to the AOPS wiki by clicking on resources. You'll find AOPS wiki, AMC 8 problems, and AMC problems just in general. And yeah, it's a great place. We got all the answers. We solved it. Yeah, if you have any questions on any of the problems, leave a comment down below. And otherwise, thank you for watching this entire thing. It was so long. But yeah, cool. Peace, guys.